Every single business plan out there, from a brand new startup to a giant company, is really built on one thing: a forecast, a guess about what's coming next. But what if that guess could be better? Today, we're going to dive into two really powerful tools, correlation and regression, that help turn that guesswork into a science.
Seriously, it doesn't matter if you're a huge global corporation or just the local coffee shop down the street. Everyone is dealing with the exact same fundamental problem.
And that's the million-dollar question, right? How are you supposed to plan for a future you literally can't see? You've got to set budgets, order supplies, hire people, all for a future that hasn't happened yet. What if you had some kind of data-driven crystal ball?
Well, that's exactly what this is all about. It's not magic, it's not a crystal ball, it's just math. It's all about looking at what's already happened, finding reliable patterns, and using those patterns to make a really educated guess about what's going to happen next. Okay, so our first tool is something called correlation. And for this part, I want you to think of yourself as a data detective. Your whole job is to sniff out clues, to find relationships between different things that seem to move together. Let's see how it works.
So at its heart, correlation just measures how strongly two things are related in a straight-line pattern. And we boil all of that strength down to one single number. We call it the coefficient of correlation, or just R for short. And believe me, this one little number tells a big, big story.
Okay, let's start in a perfect world, shall we? When R equals +1, we have a perfect direct relationship. This means as one thing goes up, the other thing goes up right along with it, in perfect sync. It's a beautiful straight line, no exceptions.
Now, on the flip side, when R is -1, you get a perfect inverse relationship. So as one variable climbs, the other one drops. Again, in a perfectly straight line. It's just as predictable, it's just going in the opposite direction.
All right, let's get real for a second, because the world is never that perfect. It's messy. So here, an R value of 0.7 shows a strong, direct relationship. You can totally see that upward trend, right? But the dots aren't in a perfect line. The connection is definitely there. It's strong. It's just not flawless. This is what most real-world data looks like.
And what about an R of 0? Well, that means there is no linear relationship. The data points are just scattered all over the place, like a random cloud. But, and this is super important, look at that graph on the right. There's clearly a pattern there, right? It's a curve. But because it's not a straight line, its R value could still be 0. That's a huge distinction to remember.
Okay, so once you have R, you can do something else that's really useful. You can square it, and that gives you R squared, also known as the coefficient of determination. I know, it sounds super technical, but the idea is actually pretty simple. It tells you exactly what percentage of the change in one thing can be explained by the change in the other. Let's make this totally concrete. Imagine a car dealership. They've got a hunch that when people have more extra cash, car sales go up. They run the numbers, and they find that the correlation R is 0.8. Okay, that's a strong relationship, but what does that actually tell us?
Well, here's what it tells us. We take that R of 0.8, we square it, and we get 0.64, or 64%. This means that 64% of all the ups and downs in new car sales can be directly explained by changes in disposable income. So what about the other 36%? Well, that's everything else. It could be their latest ad campaign, interest rates, consumer confidence, you name it.
Okay, so correlation is awesome. It helps us find a relationship and measure how strong it is. But what if we want to use that relationship to make an actual prediction? For that, we need to turn our correlation into a formula. And that, my friends, is where regression comes in.
So regression analysis basically takes all those scattered data points we saw, and it draws the one single straight line that best fits the data. And this line of best fit is going to become our prediction machine.
And that line is described by this simple little formula here. Y is the thing we want to predict, like sales. X is our predictor, maybe like ad spending. B is just the slope. It tells us how much Y changes for every 1 unit change in X, and A? That's just the starting point. What would sales be if we spent 0 on ad?
All right, enough theory. Let's put this thing to work. We're going to take this formula and use it to solve a real business problem. Let's actually forecast something right now. So here's our data. A company's been tracking how much it spends on advertising and what its annual sales are. Just by looking at the numbers, it kind of seems like more ad spending leads to more sales, right? But by exactly how much? So when we plot those 5 points on a graph, we can really see the trend.
The regression analysis then works its magic, calculating that one single line of best fit that just slices right through the data. That line is our predictive formula, but in picture form.
And this is where it all comes together. The analysis gives us our formula. Now, let's set a goal. We want to hit $32 million in sales. We just plug that number in for Y, do a little bit of algebra to solve for X, and boom, we get our answer. The model predicts that we need to spend about $89,000 on advertising to hit our sales target. Pretty powerful stuff.
But with great power comes great responsibility. This analysis is an incredible tool, but it comes with a massive, and I mean massive, warning label. If you misunderstand this next point, it can lead to some really, really bad decisions.
I want you to burn this into your brain. Say it with me. Regression does not determine causality. Just because two things move together does not mean one causes the other. This is the single most important rule of this whole game.
Let me give you a simple example to make this crystal clear. Sales at a car wash are very, very strongly correlated with sunny days. So, does going to the car wash make the sun come out?
Of course not, right? That's ridiculous. The relationship is there for sure, but the cause and effect is all wrong. There's a hidden third factor here, the sunny weather itself. The sun shining causes people to want to get their cars washed. The car wash does not cause the sun. It's a silly example, but it's incredibly easy to forget this when you're looking at complex business data.
Look, correlation and regression are a powerful lens for finding patterns, but they only show you the what. They never tell you the why. That's where your own critical thinking has to come in. So the next time you see two things moving together, don't just accept the connection. Ask yourself, what's the hidden story waiting to be discovered?